Welcome everyone to TechDaily.ai. I'm your host, David, and this is our guest, Sophia. You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit TechDaily.ai to get started today. You know, when we think about the future of tech, especially right now with AI just completely rewriting the rules of what's possible, it is so easy to obsess over the machines themselves.
Oh, totally. We get completely caught up in the hardware.
Right, the processing power, the algorithms, these massive neural networks. But if you're listening to this, consider this for a second. For the last 50 years, the ultimate bottleneck in software engineering hasn't been the hardware at all.
Not even close.
Yeah. The real barrier, the defining factor that dictates whether a project, scales globally or just collapses under its own weight is actually the human element.
It is the ultimate paradox of the tech industry, really. We spend our entire careers building these infinitely complex, strictly rational systems, right? And we expect pure logic to prevail.
Because it's code. It's supposed to be purely logical.
Exactly. Yet the success of those systems is entirely bounded by human empathy, communication, and trust. You can have the absolute most elegant architecture in the world, but if the engineers building it can't clearly communicate their intent to one another, the system will eventually rot.
Which is exactly what we're getting into today. In our material today, we are going on this fascinating exploration of that exact dynamic over the last 50 years, seen through the eyes of an absolute industry legend, Kent Beck.
Oh, he's a giant in the field.
Truly. And whether you're a seasoned developer who's architecting microservices every day or just someone who uses modern apps and wonders why tech moves in such unpredictable waves, understanding this hidden history is going to be a total revelation for you.
Because it explains exactly why the current AI revolution is breaking all the established rules.
Exactly. So to map out where we're heading with AI today, we first have to examine what the early pioneers of computing completely misunderstood about their own craft.
Right. And Kent Beck's origin story kind of perfectly encapsulates this. So back in the early 1970s, his father, who was an electrical engineer, brought home a programmable calculator.
Okay, but we have to picture what that actually meant back then.
Yeah, this wasn't a device that slipped into your pocket. This was a machine that weighed 65 pounds.
65 pounds. That's practically a piece of furniture.
It was massive, and it didn't even have LEDs.
Right. It used Nixie tubes, which are these tiny glass vacuum tubes with glowing incandescent wire shaped into numbers.
Yeah. So you have a young kid absolutely mesmerized, just sitting in front of this massive piece of machinery, watching these glowing orange numbers loop back and forth for hours.
That is such a vivid image.
It is, and that tactile, visceral connection to early hardware planted a very specific seed for that whole generation. It set up what Kent calls the biggest cosmic practical joke ever played on young programmers.
Cosmic joke. I love that phrasing.
Right, because the promise of that early era was so seductive and clean. They were told, hey, a computer is a purely deterministic machine. Therefore, if you completely understand the mechanics of the machine, you will be successful.
Basically, just master the logic of the processor and you win.
Exactly. That was the promise.
I can see why that was the ultimate introvert's dream. It offers a world completely free of human messiness. But looking back, that mindset is, it's like someone trying to become a world-renowned master chef by exclusively studying the mechanics of ovens.
Oh, that's a great way to put it.
While completely ignoring the people eating the food. You can build the perfect oven, but if the meal doesn't resonate with the diner, you've failed.
That analogy hits the nail right on the head. Because the harsh reality check arrived for him a decade into his career.
10 whole years later.
10 years of mastering the machine, and Ken has this profound realization. The actual gating factors of software engineering, the things that were actually preventing him from putting new ideas into the world, were human empathy, the ability to convince others and communicating complex ideas clearly.
The soft skills.
The soft skills. He discovered that software isn't primarily a set of instructions for a computer. It's a medium of communication between humans, just facilitated by a machine.
So the cosmic joke is fully revealed. He spends a decade avoiding soft skills, only to realize that mastering the human customer sitting at the table was the only way to scale his work.
Exactly. And because that human element proved so difficult to manage as these projects grew, the pioneers realized their existing paradigms were just insufficient.
They needed new tools.
They desperately needed new tools and practices. They had to force their code to communicate human intent more clearly to the next developer who would inherit it.
Which perfectly introduces small talk, right?
Yeah.
this incredibly influential early programming language.
Yes, Smalltalk was revolutionary. It pioneered the object-oriented paradigm. Everything in it was an object that communicated by passing messages, which maps much more closely to how we, as humans, naturally organize concepts in our heads.
And there's a specific project Kent worked on in this environment called Hot Draw.
Right. It was a graphical interface tool created back when the industry standard was mostly just green text on a black terminal screen.
Right.
And the way they approach writing code for Hot Draw is just fascinating. Kent and his collaborator, Ward Cunningham, didn't just sit in silos typing out functions. They developed this practice of literally passing the keyboard back and forth between them.
Wow, so physical collaboration.
Yeah. They were programming, but simultaneously designing and actively debating the philosophy of the architecture in real time. It was this deeply collaborative, almost conversational approach.
I read in our material today that they took this communication aspect so seriously that they kept a physical book on the desk between them, a thesaurus.
A literal paper thesaurus right next to the workstation.
That is wild.
They would halt their programming, open the book, and physically flip through the pages just to find the absolute perfect, most precise word for a variable or a class.
Because words matter.
Exactly. To them, naming wasn't just a trivial detail, it was the foundation of abstraction. If you name a variable poorly, you are lying to the next human being who reads that code, which introduces cognitive load and eventually bugs.
That obsession with intent and clear communication is the direct lineage for how we verify software today.
Oh, absolutely.
I mean, the origin story of automated testing frameworks is practically industry mythology at this point. So Kent and Eric Gamma are on a flight from Vienna to Washington.
Oh, this story's so good.
Right. They have this conceptual idea for a Java testing framework, which would eventually become JUnit. But they only have 2.5 hours of battery life on their laptop, and this is the 90s, so there are no power outlets in airplane seats.
Right, no charging halfway through.
They architected and coded the entire framework right there on the tray table before the battery died.
It's amazing. And the constraints of that flight birthed a tool that fundamentally shifted the sociology of the software industry.
How so? Like culturally?
Culturally, yes. Prior to JUnit, there was this strict, almost adversarial divide. Developers wrote the code, tossed it over a metaphorical wall, and a completely separate and often culturally lower status team of QA testers had to figure out if it actually worked.
The classic throw-it-over-the-fence mentality.
Exactly. But by providing a lightweight framework where developers could easily write automated tests in the exact same language they used to build the software, engineers were basically forced to take immediate ownership of their own quality.
Which paves the way for TDD, or test-driven development.
Yes. TDD. Kent actually recalled an ancient concept from the era of punch cards and magnetic tape, where programmers would physically type out the exact output tape they expected the machine to produce before they even wrote the program to generate it.
So they wrote the answer before the equation.
Right. And when Kent attempted to adapt that archaic concept to modern object-oriented programming, his initial instinct was that it was a genuinely stupid idea.
Well, I mean, it does sound a little backwards.
Right. Writing a test for a piece of code that doesn't even exist yet seems illogical. You are writing a test that you know with absolute certainty is going to fail.
Right.
But he forced himself to try the experiment. He wrote a failing test, then wrote the minimal amount of code required to make that test pass. And he discovered that the ambient anxiety he constantly felt while programming just evaporated.
Okay, wait. I have to push back hard on this concept. I understand the historical significance here, but isn't test-driven development basically the equivalent of reading the last page of a mystery novel before you start chapter 1?
That's a fun way to look at it, yeah.
You are rigidly defining the exact outcome up front, which to me seems like it would completely kill the creative flow of programming. You're locking yourself in a box before you've even had a chance to brainstorm the architecture.
I get that. It definitely sounds restrictive on the surface, but the mechanics of TDD actually produce the opposite effect.
Really, how?
By defining what success looks like at a micro level first, you eliminate the underlying dread of breaking the larger system. Because, think about it, when you don't have tests, you have to hold the entire state of the application in your head.
Oh, right.
You're terrified that changing one single line is going to cause a cascade of failures. TDD creates a localized safety net. You aren't paralyzed by the infinite number of things that could go wrong, so your cognitive load drops dramatically. Your creativity is freed up to solve the highly specific puzzle right in front of you.
Okay, I hear you on the safety net and reducing cognitive load. But practically speaking, doesn't that mean a developer spends half their day writing boilerplate tests for obscure edge cases instead of actually building the feature the user wants? Like, how did Kent justify the massive upfront time cost of this to management?
Well, the justification comes down to the long-term economics of software maintenance. Yes, TDD requires a higher upfront investment of time. We can't deny that.
Right.
But writing a test first forces you to use the code before it exists, which naturally pushes you toward a decoupled, highly modular architecture. You physically cannot write a pretest for a massive, tangled ball of spaghetti code.
So it forces good design.
Exactly. So the time you lose writing the test is won back tenfold down the line because you aren't spending weeks untangling a monolithic architecture and you aren't hunting down regression bugs in production. The speed comes from never having to step backward.
And the idea of never stepping backward becomes absolutely crucial as we hit the late 90s. The internet boom is just accelerating everything.
Everything was moving so fast.
It's no longer just one individual programmer trying to manage their own anxiety.
Sure.
Suddenly, it's these massive, sprawling teams struggling to deliver software at unprecedented speeds.
Yes, and they needed to scale the discipline of TDD across entire organizations, which sparked a significant rebellion within the corporate tech world.
And the epicenter of that rebellion was a sprawling payroll project at Chrysler, right?
That's the one. The initiative was completely stalled. They were burning through budget, running out of time. Kent was brought in to salvage it.
No pressure.
Right. So he evaluates the situation and makes a radical demand, he says. Send the entire engineering team home to rest, throw away all the existing code, and restart the architecture from scratch.
Wow. He literally just told them to throw it all away.
Throw it all away. And he implemented strictly disciplined 3-week cycles of planning, testing, and coding.
And he branded this methodology Extreme Programming, or XP, which, if you think about it, is a hilarious kind of punk rock name for corporate payroll software.
Oh, it was totally deliberate. He specifically chose an edgy, unattractive name, borrowing from the extreme sports craze of the 90s because he knew traditional corporate management wouldn't want to co-opt it.
That is brilliant.
He was deliberately thumbing his nose at the bureaucratic establishment that loved heavy documentation over working software. It was a calculated provocation.
He wanted to focus on the code.
Right. He wanted to elevate the actual, tangible act of programming engineers with their fingers on keyboards, dealing with the reality of the code above the endless flowcharts and theoretical diagrams preferred by middle management.
And that momentum from extreme programming led directly to the legendary 2001 summit in Snowbird, Utah.
Yes.
Where 17 industry leaders gathered to draft the Agile Manifesto.
Yes, but this is one of the funniest ironies in modern tech history.
Or it really is.
The Agile Manifesto is arguably the most famous and influential document in software engineering, and Kent Beck, one of its primary architects, completely missed the magic moment of its creation.
Because of his sinuses.
Yeah. He had a severe sinus infection, was heavily medicated, and literally slept through the climax of the story. He was out cold.
Just napping through history.
By the time he walked back into the conference room after a nap, the core tenets of the manifesto were already written on the whiteboard. Then looking at the long-term fallout of that meeting, Kent actually developed a deep resentment for the word agile itself.
You know, his hatred of the word agile makes perfect sense when you look at marketing dynamics. The word agile is completely indefensible.
How do you mean?
It's like a restaurant putting up a massive billboard advertising their food as delicious.
Oh, I see.
It's a meaningless, empty label because no competing restaurant would ever advertise their food as disgusting. Just like no competing software methodology would ever advertise itself as slow and rigid. Everyone is going to claim they are agile, regardless of what they actually do behind closed doors.
That lack of defensibility is exactly what frustrated him. Extreme programming is defensible because it requires you to adopt extreme, highly disciplined technical practices like pair programming and TDD.
You're either doing it or you're not.
Exactly. If you aren't doing those specific things, you can't realistically claim to be doing XP. But agile became an adjective that anyone could just slap onto their existing dysfunction. A company could buy a certification, change the name of a meeting to a stand-up, and claim they were agile while changing none of their underlying engineering culture.
It spawned the exact kind of snake oil consulting industry Kent was trying to prevent in the first place.
Totally.
So, okay, you have this pioneer who essentially wrote the definitive rulebook for modern software development. He has massive influence. Engineers are quoting his books globally. But then the post-9/11 tech bust devastates the industry.
The economic contraction was brutal. Kent's consulting income vanished practically overnight.
Which is terrifying.
And the stress led to severe burnout and clinical depression. The man who wrote the book on coding couldn't even look at a computer screen. His cognitive stamina was completely depleted.
Wow.
He had to slowly rebuild his brain's capacity by starting with simple Sudoku puzzles. Then he graduated over months to crossword puzzles and eventually worked his way back up to writing small scripts.
That is heavy. But, if you've ever stared at a legacy code base on a Friday afternoon, absolutely terrified to change a single line because your brain is just fried and you don't know what will break, you can kind of empathize with that level of mental depletion. It highlights that the human mind is the ultimate limiting factor here. And that rebuilding process leads to a fascinating pivot in our conversation. In 2011, at age 50, Kent joins Facebook.
Yes. Talk about a culture shock.
Right. He walks into this hyper-scaling tech giant filled with 20-somethings, and they are openly violating every single rule of software development he spent his life establishing.
Oh, it was the Wild West. They have very few unit tests, they do almost no formal long-term planning, and they are deploying code at a terrifying velocity.
According to the very playbook Kent wrote, a system operating with that level of technical debt at massive global scale should have buckled and collapsed immediately.
But it didn't.
No, Facebook was thriving. And the ultimate humbling moment occurs when he generously offers to teach an internal class on TDD. This is the concept he famously pioneered. He literally wrote the definitive textbook on it.
Right, you'd think people would line up around the block.
And 0 engineers sign up.
Yeah.
Not a single person.
None.
Instead, the young developers flocked to classes on Argentine Tango and Advanced Excel.
Which is just so funny to me.
They essentially looked at his established rules and said, we don't need this. We're building the future.
And, instead of reacting with ego, he did something truly remarkable. He decided to just observe. He played monkey see, monkey do to understand why their system wasn't failing.
He went back into research mode.
Right. And he discovered that Facebook had simply replaced his methodology with a totally different paradigm of ensuring stability, which he conceptualized as the Swiss cheese model of feedback.
Okay, let's break down the mechanics of this Swiss cheese model.
Yeah.
How exactly were they deploying untested code to millions of users without taking down the entire platform?
Okay, so in a traditional environment, you rely on extensive human QA and massive suites of unit tests to catch bugs before launch, right?
Right.
Facebook bypassed much of that by utilizing their infrastructure as the safety net. You have your local developer machine as the first slice of cheese. Then you have automated peer code reviews as the next slice.
It's pretty standard so far.
But the real magic was in shadow testing and canary rollouts. They wouldn't push new code to everyone at once. They would push it to a tiny fraction of a % of live users.
Wait, so they're basically using real users as the testing environment?
Essentially, yes. They would monitor the error rates in real time. If a metric spiked, the system would automatically roll back the deployment. Each layer of this pipeline has holes in it, like a slice of Swiss cheese. A bug might slip past the local machine, and it might slip past the peer review.
Right.
But as long as you stack enough slices of cheese together, the holes don't align, and the bad code gets caught by an automated rollback before it crashes the site for the entire global user base.
I have to challenge the brilliance of this, though, because were they actually being technically innovative with this Swiss cheese model, or were they just a monopoly getting away with reckless behavior?
How do you mean?
Like, when your profit margins are astronomical and your users are locked in, you can afford to break things, apologize later, and call it an innovative deployment strategy,
Yeah.
Weren't they just substituting good engineering with brute force infrastructure?
That is the pivotal question. And that exact question led Kent to develop his 3X model to explain the economics of software life cycles.
The 3X model.
Right. He observed that projects move through 3 distinct phases: explore, expand, and extract.
Explore, expand, extract. Got it.
In the explore phase, you are searching for product market fit with wild, cheap experiments. Most of them fail. In the extract phase, you have a mature, highly profitable product, and you are carefully optimizing for efficiency. That is where strict rules, rigorous TDD, and human QA matter deeply because a mistake costs millions.
But Facebook wasn't in explore or extract.
Exactly. They were squarely in the middle phase, expand. In the expand phase, you have found the golden goose, and your only priority is scaling the infrastructure fast enough to handle the exponential user growth.
Ah, so the rules change.
Entirely. If you apply the rigid, careful rules of the extract phase while you are trying to expand, you will lose the market to a competitor who moves faster. Facebook had specifically optimized their engineering culture to eliminate all bottlenecks to speed. The Swiss cheese model wasn't reckless. It was an economically rational adaptation for a company in hypergrowth.
That economic framing completely changes the perspective, and it actually serves as the perfect bridge to our current reality. Because just as Facebook proved the old rules didn't apply to hyperscaling, the current AI revolution is systematically wiping the slate clean for the entire industry today.
So we are absolutely being thrown back to square one.
The disruption is total. There was that recently viral quote, right, from Dario Amodei, the CEO of Anthropic, essentially claiming that traditional coding is going away and that AI models will simply take over the entire process of software generation.
Yeah, that quote made a lot of waves, but Kent's reaction to that quote is incredibly refreshing.
What does he say?
He argues that predicting the end of coding based on large language models completely misunderstands what the discipline of software engineering actually is. He views current AI coding assistants not as replacements, but as a genie.
The genie metaphor, that is brilliant.
Right. An AI genie instantly spits out 10,000 lines of code, gives you finger guns, and says, "It's all finished, boss."
But it's not.
Exactly. It provides the output, but it completely lacks the crucial human elements of context, empathy for the end user, and deep domain understanding. The act of coding isn't just a translation exercise of turning English into Python.
Right, it's not just a dictionary lookup.
No, it is the iterative process of cementing your own understanding of the business problem you're trying to solve.
Which leads to probably the most profound insight in our exploration today. Kent stated, "We are accumulating code faster than we are accumulating trust."
This cuts right to the core of the AI dilemma. Consider the epistemology of trust in software. Why do engineers trust a complex system?
Because they built it.
But more than that, they trust it because they argued over the architecture at a whiteboard. They trust it because they wrote tests that failed, and they bled over the keyboard fixing those failures. The struggle itself is what builds human trust in the system.
Wow, the struggle builds the trust.
When an AI genie instantly generates the entire application, you bypass the struggle. And when you bypass the struggle, you bypass the accumulation of trust.
You know, it is exactly like relying entirely on a GPS application to navigate a massive, unfamiliar city.
Oh, that's a perfect analogy.
Right. You might arrive at your destination incredibly fast, but your brain builds absolutely no mental map of the streets. If the GPS suddenly loses signal or confidently instructs you to drive into a lake, you are completely stranded.
Exactly.
You skip the necessary struggle of learning the route yourself, so you have absolutely no intuition to fall back on when the system fails.
That is a perfect visualization of the risk here. Because AI allows us to move at light speed without a mental map, the entire software industry has been violently thrown back into the explore phase of the 3X model.
So the old playbooks are out the window.
The agile ones, the hyperscaling ones, they are dead. Ken is very frank about this. He says, nobody knows how to best build software with AI right now. There are tech influencers rushing to publish new AI manifestos, but he points out that the original Agile Manifesto took 15 years of painful trial and error to brew.
It's way too soon.
Far too soon to claim we have the answers for AI-assisted engineering.
Yet, despite the chaos and, the collapse of the very rules he spent his life writing, Kent finds this new era thrilling, doesn't he?
He loves it. He is having a blast utilizing AI to try out what he calls his stupid ideas again.
Just like writing the first failing test.
Exactly. Because the AI genie handles the tedious minutia of syntax and boilerplate setup, he can test wild, weird conceptual architectures at the speed of thought. He has basically reverted to being a pioneer. He is entirely willing to throw away his legacy and start over from scratch, just like he did with that failing Chrysler project decades ago. He really embraces the chaos.
If you pull back and look at this whole 50-year journey, the through line is undeniable. From a child staring at a 65-pound calculator with glowing Nixie tubes, to a veteran engineer debating with AI genies that can write complete applications in seconds.
The contrast is mind-boggling.
It really is. The tools and the hardware have evolved infinitely. But the ultimate bottleneck, the true challenge of building technology that actually matters, remains exactly the same. It is how human beings communicate intent, empathize with each other, and build trust in complex systems.
The processing power scales exponentially, but the human capacity to trust a system does not.
It really is the ultimate constant. So if you're listening, I want to leave you with a final thought to mull over as you navigate your own work this week. If AI eventually reaches a point where it can write all the functional code in the world in a matter of seconds, the core value of a human software engineer is going to undergo a massive shift. The value will move entirely away from the act of producing code to the act of verifying and trusting that code. How are modern companies going to measure productivity in that future? Will we eventually stop compensating developers for the volume of lines they write or the features they ship, and instead pay them exclusively for their human judgment and their ability to cultivate trust in black box systems? Thank you so much for joining us on this fascinating exploration. Keep questioning the technology you rely on every day.